Okay, some problems with the evap. Leaky hoses are pretty common. Bad connections, rub throughs, misrouted. I've seen this happen a couple of times, especially somebody like, does an engine swap or something, or somebody, replaces the intake manifold. Some of these things can get a little weird. uh, Purge controls, purge valves, the purge solenoids or the vent solenoids, uh, those things can go bad. It is fairly common. They're put underneath the vehicle, the vent ones. Purge ones are usually up high. So it seems like the vent ones fail quite often. Usually those things are just a ground side switch. You need to be a little careful. There can be a couple of different valves underneath there on different platforms. We have like switching valves and crossover valves, sometimes they're called. And this is, kind of directing uh, traffic on the vent lines. Those guys can be normally open or normally closed. So normally open means it's just open and it bypasses all the time. You hit it with power and ground, and then it closes and it doesn't allow anything to pass. Or you have, you know, normally closed where nothing passed through until you give it power and ground and then it opens. You just need to make sure that it works, in the correct way. I'm going to show you how to test them. Really not that hard. Customer complaint? None. Uh, Maybe you get some surge at cruise, like when you're cruising steady, you can kind of feel it kind of like speed up and slow down as it's like, getting some uh, fuel in there. Generally, it'll have the mill on, the check engine light will come on and it'll alert you to a code. Probably the hard ones are the, small leak detected. Gross leak detected is usually a cap, but the small leak detected ones can be an issue because they're so small. I'm going to post up a video on using a smoke machine. Best tool in the world. EONV. This is the new stuff, and this is engine off natural vacuum. Back in the day, actually not that long ago, we had on-site vapor recovery. And what that means is when you were at the gas station, maybe some of you remember, you'd put the hose in the gas tank, the pump in the gas tank. It had this big plastic collar on it with a big spring, and you had to push it up against her. And what that was for is any refueling hydrocarbons wouldn't get released into the air. They would be recovered and brought back into the gas station where it would be condensed out and then put back into the underground storage tank. This was a very small amount of fuel. However, politicians, probably an election year, was an election year, got wind that these gas companies were taking advantage of the American consumer by stealing the gasoline that they've already paid for. Uh, it was actually mandated by the government that the gas stations put this in. The side benefit is they recovered, you know, a little tiny bit of gas, a third of a penny, or, less than a penny's worth of gas on every fill up. But, you look at like, Shell with 20,000 fill ups a day, that actually adds up to a lot of money. But they had to pay for this on-site vapor recovery at every single gas station, which was extremely expensive. So honestly, I didn't fault them for making their half a cent back. But what the government decided, what our politicians decided is that vapor recovery now needed to be done on site or in the vehicle. So on vehicle vapor recovery during the refueling process. We all right? Okay, so what that meant is it had to be built much more robust. The can got a lot bigger. It went from being, like this big to like, half a gallon or a gallon size, a big jug of carbon to get it to, recover this hydrocarbons from the refueling process. Bigger the tank, the bigger the evap needed to be. Get it? It still did the same thing, while the engine is running, still ran the same test. It still has basically the same parts. There's still, a fluid level sensor. There's a pressure sensor. There's a canister vent solenoid, normally open, and a normally closed purge solenoid. still worked the same way, still ran the same tests, but it also did this engine off natural vacuum test. And basically what this was, well, hang on, I don't have a movie. Let me get back to the picture. Okay, so the way it works is, I'll post the video. I hope it works, but the video is actually a little confusing. But here, look, we parked the car. It's hot out. The gas tank temperature is high. You know, and the gasoline, like I discussed before, the gasoline expands when the temperature goes up. So, you know, the gasoline is, you know, expanded because it's warm. And then you turn off the car, you go inside the house. The car decides to run an evap test. So it closes the vent solenoid and it waits, just sits there. And as the gas cools off, it shrinks. That causes a vacuum up here. Get it? So the vacuum up here is read by this pressure sensor. And if it sees, you know, the vacuum increasing as it drops, and it knows exactly how much gas is in here due to this, you know, fuel level sensor. It knows if it's full. It knows if it's near empty. So, you know, it sees an opportunity to do this. It just, you know, shuts off and closes the vent valve and waits for the pressure to change. Now, let's say it gets hotter. Well, that means it's going to expand, and that means it's going to go in, instead of going into a vacuum with it contracting, it's going to go into a positive pressure. It could do it either way. Now, this is over a long period of time, 30 to 45 minutes that the car is sitting there watching this. Computer's awake, you know, it's got the canister vent valve, you know, energized and shut. I mean, you can walk past this thing and go, wow, it's making noise. You know, why is it clicking and doing stuff? And that's because it's running through an evap test on this engine off natural vacuum stuff, which honestly I think is genius. I'll see if I can post up these videos. I don't know if it'll let me. And then I'm including this. Look, if you have difficult to fill, you know, like you're putting it in there and it's shutting off like every time you know, and you have to go really slow, usually this is a problem with the evap system. Or if you take the cap off and you get like a big pressure coming out, usually this is a problem with the evap. Remember, that vent solenoid is normally open, so it's just sitting there, and any, you know, expansion or contraction of the gasoline is just pushed right into the canister, you know, and then sucked back, you know. So I mean, it allows air to go back and forth in the canister. It just doesn't allow the hydrocarbons to get out. Does that make sense? Okay, so recap. Uses temperature change in the gas tanks following a drive cycle. This can either cause a pressure or a vacuum. It's capable of leak detection to 10,000ths of an inch, which is really tiny. It still runs the other test when the engine's on, and then I'm going to post up a little movie about it. And then I'm sticking this in here. This is a typical generic driveline trace to get it to run the evap test. I like this chart because it shows me where the testing is done. If I have a drivability complaint during, you know, steady cruise, decelerate 45 miles an hour and maintain for 1 minute, I'm looking at this going, well, the EGR is operating or testing itself in this spot. You know, and you look at where evap is testing itself. Well, startup, you know, acceleration, and then, you know, a sudden acceleration and deceleration. This is all evap stuff. And it monitors the O2 sensor to test the evap. And it monitors electrically the solenoids and the valves, and it monitors the pressure of the tank itself, and it does this even when the engine is off. Get it? Thanks, man. That's about it.